Okay, I hope I'm audible to all my students who are attending this particular lecture for the ECN-211, which is Microeconomics Part 2 course offered at the Queen Mary University of London. Okay, I hope you all can see the mock paper on your screens. Okay, this is the latest 2024 mock paper. Okay, and in this particular lecture, we are going to start with the discussion of the first question, which has come up in the mock exam, in the exam. Okay, so if I scroll down the paper, this is the question I intend to solve in this particular lecture. Okay, so let's quickly start with this particular lecture. So we are given that consider an economy with one consumer, one firm, and two goods. The two goods are coconuts and time. Okay, the consumer owns the entire endowment of the economy. So there is only one consumer in the economy, so owns the entire endowment, which means 0 units of coconuts and 48 units of good tea. So the consumer starts with 0 units of coconuts and 48 units of time. Okay, she can use her time either for labor or for leisure. She is also the sole shareholder of the firm, receiving all the profits pie in the form of dividends. So she receives, income from profits in the form of dividends. That's pi. Okay. We are given her utility function u as a function of xc, and xt is xc times xt. Xc denotes the amount of coconuts consumed and xt denotes the amount of time consumed. The firm can transform yt units of good tea into yc units of good c using the following technology. So we are given a concave production function if you carefully see. We are given a concave production possibility frontier. Okay. We are given a concave production possibility frontier, PPF, which shows the trade-off between YC and YT. YT is the production of coconuts. YC is the production of coconuts. YT is the amount of time. Okay. We assume that any time that is not used for labor remains available to consume as leisure time. So I can say that xt is equal to 48 minus yt. Okay, so yt denotes, I can say yt denotes the amount of work, labor work, and the total endowment of t is 48. So from 48, if I subtract the labor hours, I get the leisure hours. So xt denotes the leisure hours. Okay, part A asks us setting the price of time as numeraire, that means setting pt equal to 1, and denoting the price of coconuts as P. So PC is equal to P and PT is equal to 1. Find XC and XT, that is the utility maximizing consumer demands for goods C and T, given the price P, dividend pi that she receives from the firms as a lump sum transfer. So let's quickly come to the whiteboard to solve this. I'm just writing the main heading for completeness. We are looking at the ECN 211 course. This is the microeconomics course. Microeconomics Part 2 course. Okay, offered at Queen Mary University of London, QMUL. Okay, and in this particular lecture, we are looking at the discussion of the mock paper, or I can say the exam for 2024. So we are looking at question number 1. I'm quickly writing what is given to us. We are given that there is one consumer, one firm, and two goods: coconuts and time. Okay, so we are also given that the consumer owns the entire endowment of the economy. So I can say that the endowment of coconuts is 0, which is given to us. The endowment of time is 48 units. Okay, And we are also given that she can use her time either for labor or for leisure. So there's a labor-leisure trade-off. Labor-leisure trade-off. Okay. We are also given that pi denotes the dividends received by the consumer as profits. Dividends received by the consumer as profits. And we are given that the utility function is xc times xt, where xt denotes amount of coconuts consumed, and xt denotes consumption of leisure. Xt denotes consumption of leisure. And we are also given that yc is equal to square root of yt, where yc denotes the production of coconuts and yt denotes the supply of labor hours. And we are also given that the amount of leisure is equal to 48 minus the supply of labor. Okay, now let's look at the first part. First part is, the famous utility maximization problem which we do in microeconomics. So we are given that PC is equal to P, price of coconuts is P, that's numeraire. And we are given that PT is equal to 1. Price of time is equal to 1. Okay, so let me correct myself here, students. PC is equal to P and PT is equal to 1. So time here is the numeraire. Good. PT is equal to 1. So this is numeraire. What is our objective? Our objective is to maximize. So part A, our objective is to maximize utility, which is XC times XT, subject to the budget line. What's the budget line? Expenditure on coconuts plus expenditure on plus time, the opportunity cost of time, or I can say leisure in this case, should be equal to the income. What is the income of the consumer? PC omega C plus PT omega T. This is the value of our endowment. This is the value of the endowment. Plus, the consumer also receives dividends in the form of pi. These are lump sum dividends. So our objective is to maximize utility subject to the whole budget constraint. So I can erase this initial part off. And I can write that therefore objective is maximize utility, which is XC times XT, subject to PC is P times XC plus PT is 1 times XT. So XT is equal to PC is P. So P into omega C. Omega C is 0. So P into 0 is 0. Plus PT is 1 into omega T is 48. So I just have 1 into 48, which is 48 plus pi. So when I plug in PC as P and when I put PT as 1 and omega C as 0 and omega T as 48, this is the equation I get. U is equal to XC times XT. This is my maximization subject to the budget constraint. Okay, so now assuming that, I can say, suppose XT is measured on the on the horizontal axis and XC is measured on the vertical axis. So if I go by that assumption, if I erase all this off now, so So assuming that C is measured on the horizontal axis, C is measured on the vertical axis, and T is measured on the horizontal axis. This is the Cobb-Douglas kind of a function. It's convex. I mean, it's convex in difference curves. So I can just say that MRS is exactly equal to the price ratio. That means price of the good measured on the horizontal axis, which is 1 over price of the good measured on the vertical axis, which is P. MRS is what? The absolute value of the MRS is MU T over MUC. Remember, we are measuring T on the horizontal axis, C on the vertical axis. This should be equal to 1 over P. How do I find MUT? Partial derivative of the utility function with respect to T over MUC is going to be partial derivative of the utility function with respect to C. I put it equal to 1 over P, del U by del T, del U by del XT, I mean. This is going to be XT and XE, guys. So I can make this correction here. Del U by del XT. If I partially differentiate this with respect to XT, I get XE. And if I partially differentiate the utility function with respect to XC, I get XT. This is equal to 1 over P. So what do I get? I get XT as P times XC from this equation. I get XT as P times XC. And now putting this in the budget equation. Putting this in the budget equation. In red color, students can see this is my budget equation. So therefore, PXC plus XT is going to be what? PXC plus XT. XT, I can just plug in the value. XT is PXC is equal to 48 plus pi. So this implies 2PXC is equal to 48 plus pi. So what is my XC? 48 plus pi over 2p. And what will my XP be? XT. XT is P times XC, which is going to be P times XC is 48 plus pi over 2p. P and P cancel out. I get my answer as, if I erase all this off, I get my answer as, therefore, XT is going to be 48 plus pi over 2. So this is my answer for XT and this is my answer for X. So we have found the profit maximizing. Let me correct myself. We have found the utility maximizing values of coconut and time. Okay. So this is my answer for part A. Let's look at part B. Given the price P, what is YT? The firm's profit maximizing demand for labor. And what is the profit maximizing YC? So I need to find YT and YC. So first of all, recall that what is XT? XT is equal to 48 minus YT. If students can recall. Remember, it was given to us in the question. See? XT is equal to 48 minus YT. So from this, what will YT be? It's going to be 48 minus XT. So this implies YT is going to be 48 minus, what is XT, guys? Plug in the value. 48 plus pi over 2. So therefore, my YT will be, it's going to be, I can take 2 common, so it's going to be 96, 48 times 2, 96 minus 48 plus pi, which is going to be 96 minus 48 minus pi over 2 when I open up the brackets. So I get my YT as follows. If I erase the initial part off completely, erasing this initial part off, so I get my YT as 96 minus 48 is 48 minus pi over 2. This is YT. And what is XT? XT we are given is nothing but, sorry, let me correct myself, YC. YC is the square root of YT. See, again, if I come back to the paper, you can clearly see that YC is equal to square root of YT. So YC is going to be square root of, what is YT? 48 minus pi by 2. So these are my answers for part B. YT is 48 minus pi by 2 and YC is square root of 48 minus pi. Coming back to the question paper, let's look at part C. Find the market clearing price P. The market clearing price is where demand is equal to supply. So I can say that for part C, the market clearing price is given by the market clearing price P is given by the condition the demand for coconuts is equal to the supply of coconuts. What is XC? 48 plus pi over 2p. 48 plus pi over 2p. What is YC? YC is the square root of 48 minus pi by 2. I need to solve this equation for P. So if I erase all this off, all I have to do now is to solve this for P. So this implies if I square both sides, 48 plus pi over 2p square is equal to, if I square this, the square root will vanish. So I'll get 48 minus pi by 2. So this implies 48 plus pi square over 2p square is 4p square is equal to 48 minus pi by 2. So this implies 48 plus pi square times 2 is equal to 4p square times 48 minus pi. So my p square is going to be 2 times 48 plus pi square over 4 times 48 minus pi. 2 cancels with 4, making it 2. So I have half times 48 plus pi square over 48 minus pi, which I can write as 48 plus pi square over 2 multiplied with 48 is 96 minus 2 multiplied with pi is 2 pi. So guys, what is my P? If I erase all this off, what is my value of P? I can write, therefore, my P is going to be, so P square is this, take square root on both sides. P is going to be 48 plus pi over square root of 96 minus 2 pi. This is my equilibrium value of P. Coming back to the question paper, the last part, putting the leisure on the horizontal axis and the coconuts on the vertical axis, sketch the production possibility frontier and the most relevant indifference. So this is quite easy. All I have to do is just draw a production possibility curve and sketch it. So on the horizontal axis, we have XT. On the vertical axis, we are putting time. So let me correct myself. We are putting XT and XC. Okay, so this is XT and XC. Let me draw this clearly. We are given that the equation of the production possibility curve is YC is equal to square root of YT. That means it's going to be a concave production function. If I just differentiate this, so remember we have XT and YT, and we have XC and YC. Y denotes production, X denotes consumption. Very simple. If I do dyc by dyt, it's, if I differentiate this with respect to yt, I get 1 over 2 times square root of yt. Okay. This is what I get as dyc by dyt. And if I take the square, if I take the double derivative, it's going to be, you can clearly see it's going to be half times, take the square root of yt, it's going to be minus half times yt to the power minus 3 by 2, which is minus 1/4 yt to the power 3 by 2, which is negative. That means my production possibility frontier is concave. So this is how it's going to look like. And my indifference curves are going to be like this. I can have a family of indifference curves, IC0, IC1, IC2, and so on. Because if you look at the utility function, it's XC times XT. So I have convex indifference curves. You can clearly see the equilibrium occurs where the indifference curve is tangent to the production possibility frontier. So this is the optimum values XT star and XC star, which we have already found out in part A of the question. Okay, so with this, we are done with question number 1 completely. Okay, I stop in this particular lecture. In the next lectures, we are going to discuss from question 2 onwards. So any doubts in this lecture, students can unmute their mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.